So question 9 says that triangle RUN is reflected over y equals -3 to produce triangle R prime U prime N prime, and then that triangle is reflected over a line G to produce this final triangle. So we're starting here, we're reflecting, and then we're reflecting that ending up here. So what is the equation of line G? So let's write it out. The first reflection is over y equals -3. So again, this is our y-axis, our x-axis. Y equals -3 is going to be 1, 2, 3 over here, and this is going to be parallel to the x-axis. So y equals -3 is this line. Okay. And so we have to reflect triangle RUN over this line. Let me make sure I labeled it. Y equals -3. Okay, let's reflect the triangle. U is 2 below the line, so U prime is going to be 2 above the line. R is 1, 2, 3, 4 below the line, so R prime is going to be 1, 2, 3, 4 above the line. N is also 4 below, so N is also going to be 1, 2, 3, 4 above N prime. Okay, so there we've got our triangle R prime, U prime, N prime. Make sure you join the sides of the triangle to complete it. Like I am doing. Sorry about that. Okay, good. So, now we're going to take R prime, U prime, N prime, and we have to find the line to reflect it to give us this triangle. Well, this is yet again a very similar question. You remember that if we joined these two line segments here, these 2 points here to make a line segment, for example, that the perpendicular bisector of that segment would be the line of reflection. So we could, if we wanted to, actually join it like so and count the distance, which is 1, 2, 3, 4. So exactly halfway between, which would be right here, okay, would be the intersection of the line of reflection. That will be parallel to the x-axis. So let's draw line G. Okay, so this is line G. So when we reflect the triangle with R prime, U prime, N prime, we're getting R double prime, U double prime, U N double prime. So the equation of line G is then what? It would be 1, 2, 3. It would be y equals 3. Okay, y equals 3. And what single transformation is, and here I think this is just a typo, you need to correct it in your notes here. We're not talking about this triangle, we're talking about the original triangle, triangle RUN. So what single transformation would take the original triangle RUN to the final triangle with the double primes? And you can see that that would be a movement. R to R double prime is an upwards movement. We're only moving in the y direction. There's no x component. So the transformation would be 0 in the x, and then to figure out what it is in the y, we just have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, they should all be the same. Let's double check by counting U. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 12 positive in the y direction. This would be the transformation T of 0, 12. Note one other very interesting thing. The orientation of our original triangle, RUN, is clockwise. Okay, if we read it as RUN, we're going clockwise. As we've seen in the past, when we do a reflection, we reverse the orientation, so that the orientation of this triangle is now RUN counterclockwise. But then when we do a reflection on this triangle, we then go back to the original orientation. We switch it once from clockwise to counterclockwise, and now we switch it back to clockwise. Okay, so now the final double prime triangle has the same orientation as the original triangle did. So that's another reason why two reflections equals a translation, because two reflections reverses and then restores the orientation. So what we're left with is the same orientation and just a movement in a direction.